So let's take a look. For part A should have been pretty easy. We're looking for h prime of 2, which means the derivative of h at 2, or the slope of the tangent line of h at 2. And if this line is tangent to h at x equals 2, you just need to find the slope of that line, which is 2/3. So that one was worth just 1 point. Everybody good there with part A?
Yeah.
Yep.
All right, part B says we've got a new function, a of x. A of x is 3x cubed h of x. And so they want you to write an expression for a prime and find a prime of 2. So a prime of x, part B, a prime of x should just be the product rule. So it'll be 3x cubed h prime of x plus 9x squared h of x. And the expression here, let's see. What did they do? So as long as you, as long as you showed that you were trying to use the product rule and you used it properly, you got a point for that. Plus, if you got the, this is really just worth 2 points. They say product rule is 1 point, and then a prime of x is the second point. So I'm not sure exactly how they break that down, but to me, that's 2 points right there for that. And then to find a prime of 2, well, that would be 3 times 2 cubed times h prime of 2, which was 2/3, plus 9 times 2 squared, plus h of 2, which they gave us as 4. So it looks like, I don't know, what does that come out to be there? The 2/3 and the 3 there cancel out, so that's 2 to the 4th power, which is 16, plus another 16 times 9, which is 144, so that'd be 160. And that was another point if you got that value at the end. Any questions there on part B?
Nope.
Okay. Part C says h satisfies this equation. H of x equals x squared minus 4 over 1 minus f of x cubed when x does not equal 2. And so we also know that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. So we want to find f of 2 to begin with. And so if we want to find f of 2, since we know that that this is 0 over 0, we should be able to go in and figure out the value of f of 2 here, right? F of 2 needs to be equal to what? Should be equal to 1, because if we make this, 1 minus f of x cubed needs to equal 0. That tells us that f of x cubed needs to equal 1 when we evaluate at x equals 2. And so f of 2 needs to just be 1, just based on what we know about L'Hopital's rule. Everybody good with that?
So you didn't actually have to use L'Hopital's rule?
Well, not to find f of 2. We're going to have to use it to find f prime of 2.
Okay.
Yeah. So let's see here. Next, the next part of this, let's see. Yeah, we just want to use this to find f prime of 2, right? Yeah. So we know, if we know that this is a twice differentiable function, we know that the derivative of this exists, or derivative of g and h both exist. We know that the second derivative of them also both exist, which means we know that the derivatives of g and h both have to be continuous at all real values. And so we know that when we take the derivative of the top and the derivative of the bottom of h of x, if we're looking for the limit of it, we know that we should get 4. Right? So we should be able to go in and say that the derivative of the numerator, which is just 2x, over the derivative of the denominator, which, what was it? Was 1 minus f of x cubed, right? So that'd be negative 3 f of x squared times f prime of x. And so now we're evaluating this at 2, and we know that this needs to equal 4 because we know that h of 2 needs to equal 4, so the limit as x approaches 2 of h of x must also be 4. And so then we'll just plug in the stuff that we already know. So we already know that f of 2 was 1, so this is now looking like 4 equals 2 times 2 over negative 3 times 1 squared times f prime of 2. And so we're just going to use that to solve for f prime of 2. And so cross multiply f prime of 2, divide by the 4, cancels out with the 4 in the numerator. Looks like we just have a negative 3 in the denominator, so it should be negative 1/3. Any questions on any part of that?
Can you explain how you got the what you got in the denominator? How you got the derivative of what's in the denominator?
How I got the derivative of this, like the negative 3f of x squared times f prime?
Yeah.
Yeah, so 1 minus f of x cubed was the original denominator, so we're taking the derivative of that. The 1 goes away, so that's just a 0. The negative is a constant, so it just stays out in front. This is a function being cubed, so it's like u cubed with u equal to f of x. And so to take the derivative, that's the chain rule. It's 3u squared, so that's the 3f of x squared, and then times the derivative of u, which would be f prime of x.
Okay.
Does that make sense?
Yeah.
Cool. And that part I think was worth 4 points. Let's see here. Yeah. So it was 2 points for the first part up here and 2 points for the second part. And I guess, well, one of the points down here was for correctly differentiating and one was for getting the answer. Good or no? Okay. And then part D, what did part D ask? So we know that g of x is less than or equal to h of x for between 1 and 3. And we have k being a function satisfying g is g and h are sandwiching k, basically. Is k continuous at x equals 2? Well, the answer there should be yes. Since, what is it, g and h? Since g and h are both differentiable functions, they're continuous. They're differentiable on the entire interval from 1 to 3. And if they're both continuous, then the function that is sandwiched between them needs to also be continuous, since these values, they say they all exist, right? For all values between 1 and 3, these functions exist. So just the sandwich theorem.
If you just say yes due to the sandwich theorem and then like do some basic other explanation, but like don't like talk about what you just said about how they're differentiable, would you still get the points?
You need to state somehow that they're continuous, right? That g and h are both continuous at x equals 2. And since, I mean, you'd have to have some sort of explanation about the continuity.
Okay.
Yeah. So, I mean, the best thing to say would be something like, we know that the limit as x approaches 2 of, what was it, g and h, right? G of x equals the limit as x approaches 2 of h of x, and they're both equal to 4. And so we would say by the sandwich theorem or the squeeze theorem, the limit as x approaches 2, what was it, k of x, is also equal to 4. I mean, that'd probably be the best way to put it. And if the limit as we approach 2 of k of x is equal to 4, we should be able to say that, I mean, basically from there, it's good enough. We just say that it must be continuous at 4 because the other ones were continuous, and that it's guaranteed always to be less than or equal to it. And so it can't have any undefined values. But
Would you make a point if you didn't do the limits part?
I think so. I don't know. This one was on the 2019 test. It's not the best question, honestly. It's kind of, I don't know, just the way it's worded is, and the way their explanation is just not so good in the scoring guidelines. I mean, because obviously, I mean, you don't even really need the sandwich theorem to prove that it's continuous. I mean, you can just say, look, I mean, it says that that we've got this function is, you know, sandwiched between these other two functions. I mean, it's got to be between them, and we know that if we've written this inequality, we're saying that that means that all of these things should be defined at all of these values. And so if it's defined at all these values in between these two things, and it's defined on this entire thing, you just need the basic little sandwich theorem piece saying that it must be continuous at 2 because the other ones have the same value at 2. So I think, yeah, I mean, I don't know if that answers your question. It's not a really well worded question on their part, in my opinion. But
okay, thank you.
Any other questions on that one? So first part of it, well, first off, we got this nice chart with f, f prime, g, and g prime. And we know that both f and g have continuous second derivatives. And we're going to look at a new function, which we're going to call k of x. K of x is f composed of g of x. And we want to write the equation for the line tangent to the graph of k at x equals 3. So we're looking for k prime of 3 to find the slope so that we can write the tangent line. And we also need to find k of 3. So first off, k prime of 3 is just the derivative of this. And so since this is a composition of two functions, you have to use the chain rule. So that should be f prime of g of x times g prime of x. That's just the chain rule. And k of 3 will just be f of g of 3. And so same thing here, to find k prime of 3, we'll just plug in 3's for these. So this is f prime of g of 3 times g prime of 3. Everybody good with that so far?
Yes. Yes.
Cool. F of g of 3 means plug in 3 into g of x. So g of 3 is, according to the chart, 6. And so then this becomes f of 6, and f of 6 is 4. And then up here, g of 3, like we said, was g of 3 was 6. So this becomes f prime of 6. And then g prime of 3, which is 2. So 2 f prime of 6. F prime of 6 is 5. So that should be 10. Everybody okay with that?
Yeah.
Okay, so we should end up with y minus 4 equals 10 times x minus 3. And let me see here. I didn't pull up the guidelines for this one. Let me see here. 3 points for that, it looks like. So 2 points for getting the right slope, 1 point for having the right equation. Any questions on part A?
Can you quickly repeat how you got the slope?
Yeah, so the slope is, the derivative of k, right? That gives us the slope. So we take the derivative of f of g of x. That's the chain rule. Since it's f of g, you take the derivative of the outer function, f prime, and evaluate it at the inner function. So f prime of g, and then times the derivative of the inner function, right? That's like having the function f of some function u with u equal to g of x, right? So it's derivative of this, f prime of u, and then times g prime of x, and u is g of x. So that's how we got this. And then g of, we're evaluating at 3, so g of 3 and g prime of 3, and then g of 3 was 6, so we put in the 6 there. And g prime of 3 was 2, so we put in the 2 there. And then f prime of 6 was 5, so 2 times 5 gave us 10. Does that make sense or no?
Yeah.
Cool. Anybody else? Any other questions on that? All right. Part B says we've got a new function, h of x, which is g over f. We want to find h prime of 1. So first we'll find h prime of x. And since we had g over f, right? So should be the denominator times the derivative of the numerator minus the opposite of that, the derivative of the denominator times the numerator over the denominator squared. And if we want to find h prime of 2, we'll just evaluate all of those. I think we were finding h prime of 1. H prime of 1 out of the f of 1, g prime of 1 minus g of 1, f prime of 1 over 1. So then you'll just have to go back to your chart and look at what each of those things is. So let's see, f of 1 is -6. I'll have -6. I'll have a -6 squared in our denominator. G prime of 1 was 8. G of 1 was 2. And f prime of 1 was 3. So whatever that comes out to be, -48 minus 6, which is -54 over +36. Those both ought to divide by, what are those both divide by? 18, right? So -3 over 2. And 2 points there, 1 for, sorry, 3 points there, 2 for the expression and 1 for the final answer. Or actually, sorry, that's not right. 2 points for the expression of h prime of 1. So you had to actually plug in 1, and then 1 point for evaluating it correctly. Any questions there on part B? All right, part C, I believe was the integral from, was it 1 to 3 of f double prime of 2x? That's right, yeah. So if this was just f double prime of x, it'd just be f prime evaluated from 1 to 3, but it's not, it's f double prime of 2x. And so in order to do that, we've got to let u equal 2x, which makes du 2 dx. So we're going to have to put in a 2 in here and a 1/2 outside. So we end up with 1/2 the integral of f double prime of u du. And we're going to evaluate that from 2 to 6. And so that ought to give us 1/2 of f prime of u evaluated from 2 to 6. And then let's see, did our chart have 2 and 6 both on it? Yeah, it did. So if we plug in, let's see, f prime of 6 was 5, and f prime of 2 was -2. You end up with 7/2 as your final answer. Any questions on that?
Do you not have to plug 2x back into u?
You do not have to. If you want to, you can. So alternatively, we could have said this becomes 1/2 of f prime of 2x. But if you do that, when you turn it back into x, then you have to put these limits back to what they originally were. So 1 and 3, if you
I
were
see.
converting x, and so then it effectively becomes the same thing. But you don't have to. You don't have to convert it back. Let's see, and that was worth 3 points, 2 points for having the right, antiderivative sort of thing there, and 1 point for the answer. No, yeah, you don't have to show the u substitution. Just make sure if you just do the u substitution in your head, which is, that's normally what I would do, but just make sure just make sure you don't screw it up. Just be careful with it. But no, you don't need to show it. In fact, I don't think they even showed it. Yeah, they didn't show it in their scoring guidelines. So. Any other questions on that one?